Hi, this is Chris with Sanderson Test Prep, and in this video we're going to take a look at applying L'Hopital's rule in a couple calculus questions. So L'Hopital's rule tells us that when you're given a limit of a fraction, you can separate the numerator and denominator and take the derivative of each if your limit is otherwise going to give you something undefined. So here, for example, we can treat this as the limit as x approaches 0 in this case, but it works as x approaches any value, whether it's infinity or 8 or negative 13. So here we're going to treat the numerator and denominator as two separate functions, f of x over g of x, and that's going to equal the limit as x approaches 0 of f prime of x over g prime of x, which is a very fancy mathy way of saying that you're just going to take the derivative of the numerator and denominator separately and then see if direct substitution will work after that. All right, so here's our basic structure, but now let's apply it on this specific scenario that we see here. So here, the limit of this function as x approaches 0. So as is, with direct substitution, you'd get sine 0 over sine 0, which is going to be 0 over 0. When you're dividing by 0, that's undefined. So we don't want to end up there, and that's where we recognize that this might be a good time to apply L'Hopital's rule. So if you're looking at a limit, you don't want to jump immediately in. You should always test out whether or not direct substitution would work. In this case, it doesn't. So now we have to apply L'Hopital's rule. So let's take the derivative of our numerator. Derivative of sine is cosine. And then through chain rule, we take the derivative of the inside. So that'll be times 6. And our denominator will be cosine of 2x times the derivative of the inside is times 2. And just for good measure, I would probably, just to try to build good habits, I would write the constant that is being multiplied by out front as a coefficient. It's just going to be the way that you'll usually see this written. So like I said, mathematically the same, but builds a good habit whenever you're multiplying by a constant, try to write that out front as a coefficient. And then here, now let's see what happens if we apply direct substitution. So when you plug in a 0 for x, we get 6 times the cosine of 0 over 2 times the cosine of 0. And using our unit circle knowledge, so the cosine of 0 is 1. So this is 6 times 1 over 2 times 1, which is just 6 over 2, which is 3. So now we get one constant as our result. We get a concrete value for this rather than something that is undefined by using L'Hopital's rule. So this is an example where we take the derivative of the numerator and denominator, and then it allows us to get a particular numerical result. Now, let's try another example. Because sometimes it doesn't work that easily. Sometimes we have to do a little bit extra. And one nice thing about this rule is you can apply that derivative approach as many times as necessary. So let's take a look here. If you plug in infinity with direct substitution, we just get infinity over infinity. So we say no thanks to that. I want to see if I can get a more definitive answer. And let me apply L'Hopital's rule and see where it goes. So we do the limit as x approaches infinity of, so our first derivative here would be 10x for the numerator over, and e to the x, the derivative is e to the x, so that one is easy on us. We just rewrite that. Let's try direct substitution now. Look at that, infinity over infinity. Again, no thanks. So in the previous example, we were able to just do the first derivative. Now we have to do a second derivative. Let's take the derivative one more time and let's see if that helps us out. And like I said, one nice thing is you can apply this as many times as needed. So here, If we take the next derivative, we get 10 over e to the x, and when you do direct substitution here, now you get a constant. You get 10 over infinity, and any constant over infinity is equal to 0. So now we have our defined answer by applying L'Hopital's rule, and in this case we just had to do the derivative 2 times. So if you're using L'Hopital's rule, you take the derivative of the numerator and denominator separately. If you come up with something that still gives you a limit that you can't define or find a concrete value for, it doesn't mean you've done anything wrong. Try taking that derivative again and again and again if you have to, but eventually, if L'Hopital's rule is applied, you will get to a place where you can convert something that's not definable into something that'll provide you with an answer that's constant. For more, please check out our other videos.